Correct.
So it doesn't make sense for this guy to say, oh, I asked for a SkyGate, you gave me that, by the way, it's not responding. Right?
Okay.
So that should be like, we don't want to involve every client also involved in the health check protocol, right?
Plus,
we want to leave between these two.
I think the other point is that we cannot, there can be a temporary network glitch. For that, a single act may not come, say. So we have to have a retry mechanism and make sure that for a period of time the SkyGate is not available.
That is fine. My question is completely orthogonal to that actually. So what you guys are talking about is Stargate wants to do something. It already knows about the SkyGate currently, say. So it's been carrying out its business with that SkyGate, and it doesn't respond.
Yeah.
So it will go back to Skybridge and say that I didn't find this, and it will hand it a new SkyGate. That's fine. What I'm saying is, why do we need this TTF? Why do we need a heartbeat mechanism on the SkyGate itself? Instead, so here's the protocol that I'm proposing. The SkyGate talks to Skybridge registers. It's fine. Okay. Next time when a request comes through, Stargate is not talking directly to SkyGate, is it? Isn't it going through Skybridge all the time?
No, it's going direct.
I see. Okay.
It's going direct. So this is just a discovery service. Data doesn't flow through here.
Okay.
So you basically ask for a SkyGate, then you start directly make a TCP persistent connection here and just start talking, sending all the data streams.
Okay.
And that's one of the retries thing. This is why I said the retry logic is not in libconf. It's because the way the retry works is every client is a slightly different retry, SkyMap versus Stargate. What Stargate does is it tries to reconnect to the same SkyGate few times because it will try to reach out. There could be a network glitch, connection disconnected. It'll try again. After some number of tries here, it'll go back to this guy saying, hey, give me a SkyGate. If that guy sends off the same response, it'll try again. So now there's a different level of loop. Retry. At a higher level, retry, go back to this guy. Somewhere at least the stale state will get cleaned up and you'll get a new one at some point. So it retries, for example, right now I think every 5 seconds it'll try to go back to this guy, and every 5 times or something it'll try to go back to this guy saying, hey, I tried for 25 seconds, I didn't get it here, it'll go here.
One question. So the libcon based connection through HTTP or RPC also, so that is mostly used between host A and host B, right, which are different machines, remote machines, right? But you also told that there is a case when a star agent actually talks to Stargate using the same, and they run in the same host.
They're running in the host and in the VM.
Oh, that way it's actually virtually different.
By the way, you can even, actually I think there's some places where we use it on the same machine also. StarNet and Stargate are on the same machine, they talk to each other.
So isn't that an overhead of actually using this?
As opposed to
some lighter communication between these two processes, because it can be some different IPC?
You can have a local message queue, for example.
Yeah, correct.
I mean, you can do shared memory, but at some level the abstraction gets easier, right?
Yes.
If you're really doing high bandwidth, most of the time StarNet and Stargate is not a data streaming. Star agent to Stargate is data streaming, and that's why the overhead of an HTTP header in front of it is not significant enough. And let me tell you, this is for a future sort of a thing, right? Why would actually do that? So for example, theoretically you could reduce the number of ZVMs where they're not one-to-one with Z host. So multiple hosts can actually talk to the same ZVM.
Yeah.
Then you're basically going across the network to talk somebody VM or another, then you still wrap it in HTTP. And we don't, who knows what network it's going through to talk to the other host.
Yeah.
So I mean, if it's the overhead of doing this, for stats is the only place to worry about it. Rest of the place, the overhead doesn't matter. Right? The data is not happening. In stats, whatever size we have for the stat boards, the extra HTTP headers are about, I think, few hundred bytes, right?
Yeah, the stat boards are heavier than the headers.
Yeah. And also we can collect, we haven't tuned the whole thing, we can collect more number of samples of stats, even though our sampling frequency is high, put them all together in one message, compress them, and still have a small amount of headers. So we have to sort of balance, we have to do more bandwidth studies, how much we're consuming and all that stuff. We're doing as of now calculations rather than studies and tuning it.
Yeah, we did it last week, right? I mean, it's not that much.
Yeah, it's not too
few
much.
MBs.
So one thing is now, this one, right? So we basically have this service register. It registers, what does it register?
You're telling the story.
It registers SkyGate service. It also registers Sky Commander service. Okay? So every SkyGate does not register the Sky Commander service. What the Sky Commander service registration means that there is a connection from some star commander to this Sky Commander. So when this thing is registered, it means some other process can talk to this guy to reach this star commander. So this registration of Sky Commander implies that, hey, I know a way to get to some customer machine. That's what this registration means. Skygate basically is registering saying, I'm here. It doesn't even need to have any client connections or anything. It's just a process, I'm here. So clients can discover Skygates and other people can also discover Skygates. Whereas when you actually register a Sky Commander, it's with a specific customer information and a machine information. They say, hey, there is a way to reach this guy through me, and that's what is registering.
Basically proxy.
So Sky Commander is tied to an account ID and a machine?
Yeah, so the way the Sky Commander is registered, first thing is let's talk about when it's registered and then what is the meta information with it, right? So now whenever a Stargate is running, it instantiates different modules, and then it's just Stargate to Skygate connection is just a TCP connection, right? And we're just sending bunch of stuff on it. When we send command poles, and these poles reach the sky, right? So we have the pole store, right, which has command poles. So these pole stores are the ones that are used to figure out all the different guys connected to me, because one Skygate might actually have multiple star commanders from different customers talking to it. Different machines, different customers, different clusters, right? So then the command pole has information about, hey, where am I coming from in the header, not in the command pole itself, but in the header it has information where I'm coming. We use that information to go put in the pole store saying, hey, if you want to reach, and the information that we store there is account ID, cluster ID, host ID. And now when we register this in this thing in SkyBridge, we actually register it in multiple keys, because there's a key value lookup. I mean, registering is discovery services service lookup with a key value. Now it's not just a Sky Commander, it says, oh, Sky Commander for this account ID is here, Sky Commander for this cluster ID is here, and Sky Commander for this host ID is here. And there's a reason for it, because in the beginning when a machine just connects, it doesn't have an account ID till you do a validate account. It doesn't have a cluster ID till you create a cluster, right? So it only has a host ID right at the beginning. Now to reach a host ID, you have to be able to know which account has which host ID, and based on that mapping, try to get to it.
Why do we need that? Because host IDs are UUIDs, right? Once you have host ID, you know which machine it is.
Yeah.
It's unique.
No, so in the beginning, when you're trying to reach a specific host ID, you can use the host UID. But there's a lot of commands that you don't care about the host ID.
But we can
So
do
any
the
host in the
translation on
cluster.
our side, right? Given host ID, we can always figure out which account ID, or given
It's very much
account
so.
ID, cluster ID,
Yeah.
we can always figure out.
Yeah,
host
so the
ID.
thing is, but from the UI, when you're trying to send a command, saying do an OpenStack cluster create, or
Okay.
do some Ceph command, then it doesn't need to go to a specific host. It's an OpenStack cluster command, right? So either you figure out from the UI which cluster, where is this cluster? From the cluster, you map a list of host IDs,
Right.
and from the host IDs, you can pick one
Yes.
and direct it to the host ID.
Yeah.
But instead of putting all that logic in SkyMap to go look up multiple tables,
I see.
basically says, this is the cluster ID you want to go to. Send it to a host. And then this guy comes here and says, oh, this cluster ID, what is the list of commanders available?
I see.
Picks one and just sends it.
Okay.
So you can randomly, we can put more logic over time, because given this one in the Sky Commander, right, given a cluster ID, it will return you a slice of host. Now it's your job to pick up, how do you get to this thing?
Yes. So every Sky Commander corresponds to one host ID? Like I want to know basically if I
No,
have
multiple, because multiple of them can connect here, right?
Oh, so one
Even
Sky
from different
Commander,
accounts, different clusters, different hosts.
there is one-to-many relationship. Wherein one Sky Commander can cater to multiple accounts or multiple clusters
Yeah.
or multiple hosts.
Yeah.
And multiple of these things at the same kind of time.
Yeah.
Okay.
One host has only one Sky Commander, but one cluster might actually be connected to different Skygates also.
Okay.
Right? Within one cluster, we have multiple machines, they could all be talking to different guys.
Okay.
And this is where the lookup thing now kicks in. Now, once we register with this one, right? Now, whenever the UI is talking to the Sky Map is our backend for the UI, right? And when the UI sends a command saying, here, send this command to this account ID and cluster ID, what he's basically doing is he actually looks up the same locate request with keys and service, saying, okay, I want to send a command, give me a Sky Commander location with this properties, account ID, cluster ID, or account ID, host ID. It asks for that. He sends a response back, locate response, and then he finds which Sky Gate is the location, and he sends that command to the commander. So this is how the command comes in. And then he looks up the cold store, finds something, and then sends it back here. So this registry part of it, you can actually look up the SkyBridge. If you look at some of the, so we have the DCLI. We have a CLI in the Sky which lets you explore these connections. So each of these services, SkyBridge, SkyGate, SkyMap also has an interface, but there's no state information there. These guys have state information which you can do curl and get out. So for example, the SkyGate will actually print the list of connections to it right now and the list of poles that are available. Obviously at different levels, because pole store is pretty complex store with locking on it, because it's a shared resource. So which means if you actually try to dump the pole store information, you have to take a lock, it's slower. So without that, just the list of connections again is a different log, different set of information. So there's at different debug levels. It's a curl process ID :port IP :port /status. The question mark debug equal to 1, debug equal to 2. It prints more and more information. It takes more and more logs and prints more information.
Okay. Why do we have separate SkyMap service? Like I understand why SkyBridge is there and why SkyGate. What does it do?
So the SkyGate service, the purpose of SkyGate service is to do the data stream processing. And if you take a look at the Sky database, right? There is a database here, which is Cassandra and Redis. Okay? The SkyGate is basically getting data from here, and SkyGate is the one which pushes that data into the database. Writes. Okay? SkyMap is a UI backend which serves as the reader. Mostly read, little bit of write.
Okay.
The SkyMap is the one which does all the REST endpoint for the UI backend. So it serves give me account information, give me projects, give me VMs, show me stats. All of that logic, all of that handlers are in the SkyMap.
So the intelligence is mostly in SkyMap and SkyGate for the data processing.
Yeah.
SkyGate also rarely, as far as I can tell, rarely does any data processing. It streams it, actually,
Also
records it.
only in
So,
SkyMap.
however you want to aggregate the process, etc.
So we'll talk about the data processing. I'll draw a little bit bigger picture.
Okay.
I mean, the rest of the part is fine, right? I can draw the picture for how the data is flowing.
Question here. So is there any load balancing between multiple sky maps from?
So we have multiple sky maps which are again fronted by HA proxy as of now.
Okay.
But the idea is that over time we can scale each of these differently.
So from UI, it always fetches the data from Cassandra. When we
No,
when at
not
real time-
always. Actually, no, it's a combination of Cassandra and OpenStack directly.
Okay.
So let me show you that.
And of course, some of it can be cached in Redis, right?
Yeah. Right now, only the sessions are cached. We don't actually cache actual data, but that's something to build in. So the way, if you only look at the Sky part of it, SkyGate is the module to which stars are talking. And then there is a Cassandra database. And this uses a Chronos library. It's not a process, it's just a library to talk to it. And it uses Kairos through another library to talk to Cassandra.
Why do we need both? I mean, what
Yeah.
are the differences?
So
Actually-
Kairos is pure stats data. Chronos is for everything else, inventory, events and all the other stuff.
Actually, even the StatsDAL is a Chronos library.
Yeah, so actually Kairos is sitting underneath here in it.
Yeah.
So, and So the idea is that what we are doing is there's schema for anything, right? Once you want to store read and write data, there's schema to it. So we've defined schema for all the events and accounts and regions and everything that we store here. And obviously we had to pick all the primary keys, secondary keys, and your clustering keys and all that stuff. Cassandra is NoSQL. So you also have to do some intelligent schema design for how we want to store data and what are the different tables, depending on what lookups we want to do. We spent some time in this schema design last year. So we store all of this now. So for stats also, you could do your own schema design, which we actually, there's code in Kronos which is now deprecated, which we don't use, which also does this time series data schema. Like, it sort of says, okay, one row will have this, this data point by this, and each stat becomes a different row and all that stuff. So now, but then we had to do more, the write part of it I was doing, and then the read part of it also, you had to do processing of the read part of it you had to do. So what Kairos gives you is a library, which gives you a time series interface. So you can actually store time series data, load time series data, and do operations on it with respect to aggregates and sums and averages and all that stuff. At some point, we could use a different library or write our own thing, but as of now, this is the faster way to get this done. And it's been heavily used, so it's relatively stable. And now SkyMap, for the data part of it, also talks to Kronos. So effectively, when you're implementing write of any data coming here, sort of also implement the read, and that's sort of looked up here. So the handlers for handling the routes are from the UI are here. And then this thing is actually just doing raw Kronos calls. There's no HTTP serving here. And the reason to separate it out is basically because this is dependent on the UI. How many customers are currently logged in, then this is serving all those customers, right? This is dependent on machines. How many machines are connected, what are they sending, right? So you want independent scaling of these two. So that's the reason these things are separated out. And so in future we can scale them differently.